Uses. The U.S. Air Force has many large drones. They weigh thousands of pounds and can fly more than 50,000 feet, 15,240 meters above the ground. Radioplane OQ-2A. The Radioplane OQ-2A was a remote-controlled target drone flown in 1943. It had to be launched by a catapult. The OQ-2A had a wingspan of 13 feet, 4.0 meters, and weighed 108 pounds, 49 kilograms. The OQ-2A could fly 8,000 feet, 2,400 meters high. A Radioplane OQ-2A is on display at the National Museum of the United States Air Force in Dayton, Ohio. These drones cost millions of dollars. Some micro drones may weigh only 1 ounce, 28 grams, and cost less than $100. Larger drones are typically built by manufacturers, but there are also do-it-yourself kits for building your own drone. It is impossible to say when the first drone was invented. Some believe it was in 1849. In that year, Austria used balloons filled with bombs during a war. Others say the first drone was invented in the 1930s. That is when the United States first sent up remote-controlled aircraft. These devices were practice targets for the Army. Inexpensive hobby drones are available at many stores and online retailers. Drones may have begun with the military, but by the 1940s, things changed. Remote-controlled aircraft became a hobby for civilians. Today, more than 1 million people own hobby drones. Chapter 2. How Drones Work. Hobby drones come in 3 categories. The first is planes and gliders. These drones look like a typical piloted aircraft with 2 wings and a tail. They can only move forward. They cannot hover. Propellers are usually pointed horizontally. The second category is helicopters. Helicopters have propellers or rotors pointed vertically. These drones can move forward, backward, and side to side. They can also hover. The third category is multicopters. These drones typically have 3 to 8 rotors. Multicopters move like helicopters. Multicopters are the most popular type of drone. All drones must be able to get up in the air. Lift is what makes objects that are heavier than air stay aloft. Lift happens when air is moved across wings and rotors. The upper surface is curved, and this makes the air move faster. Faster moving air results in low pressure, which creates lift. Heavier aircraft require greater lift. Drones carrying cameras sometimes have 6 to 8 rotors. Once the drone is in the air, it needs instructions on what to do. To control the drone, a pilot sends commands by radio frequency to the aircraft. GPS technology helps the drone navigate. Radio frequency communication requires a wireless connection by means of radio waves. A drone and its control device are matched together and recognize each other. Wi-Fi is a wireless internet connection that uses radio waves. Wi-Fi also allows drones to send live video to computers, tablets, and smartphones. GPS is mainly used to guide the drone in flight. A pilot programs the mission of a drone before the flight. The pilot puts in GPS coordinates. The drone flies to the programmed locations, gathers data, and then flies back again. A drone's Wi-Fi range is approximately 650 yards, 600 meters. How it works: roll, pitch, yaw, and throttle. Roll tilts the drone left or right. This happens by speeding up the rotors on one side and slowing down the rotors on the other side. Pitch tilts the drone forward or backward. This works in a similar way as roll. However, the front and back propellers are the ones that speed up or slow down, rather than the propellers on the side. Yaw rotates the nose of the drone left or right. This happens by speeding up the rotors spinning in one direction and slowing down the rotors spinning in the opposite direction. Throttle controls the drone's up and down movement. This happens by changing the speed of the rotors all at the same time.